Inverse functions. In this section, we want to learn how to find inverse function. Inverse functions are the functions that undo whatever the function is doing. And one of the requirements for every function to have an inverse is being a one-to-one function. In section 2.1, we explained about the one-to-one function. We said the function is a relation between the input and output. For every one x, for every one input, we should get one output or one y. One-to-one function tells us that for every one output, also we should get one x. And why that's a requirement for having an inverse? Because if the function is not one-to-one, when you find the inverse is not a function anymore. So if you want to have an inverse function, you have to make sure that the function is one-to-one. And what inverse function is doing, for example, if we have a point of 2 and 4, if the input of a function is 2 and the output is 4, for inverse function, the input would be 4 and the output would be 2. It's kind of switching x and y, switch input and output. If input of the function is 6 and the output is 12, in inverse function, the input is 12 and the output is 6. If a function have an inverse, since the inverse is undoing whatever the function does, when we find the composition of two functions, FOG or GOF of a function and its inverse, since they are canceling each other, they are undoing whatever the other function is doing, so the result must be end up to just x. So if f and g are inverses of each other, their composition is always equal to x. Or we can say, if we have a function f, we always show the inverse function by f inverse, or f with the -1 on top of that, which is called f inverse. If f and f inverse are inverses of each other, the composition of these two functions is always equal to x. Let's look at example 1. We want to determine if these two functions are inverses of each other. We want to know if g is inverse of f. Let's see. If they are inverses, that means their composition must be equal to x. So we need to find FOG and GOF. They both must be end up to just x. They should cancel each other to just get x at the end. FOG, which means f of g of x. That means I need to start with function f for x minus 2, and then I need to replace the x in function f with g of x. For GOF, I need to start with function g and replace f into the function g. So function g is -2x plus 4. And instead of x, I put the whole function f. Now let's simplify each of them and see if we get x at the end. So let's distribute to drop the parenthesis, which is -8x plus 16. We also have a -2, combine like terms. So we have -8x plus 14. Or for this one, distribute -8x, -2 times -2 is +4. And if we combine like term, we get -8x plus 8. So as you see, none of them is equal to x. So what does it mean? No, they are not inverses. Okay, so f and g in this example are not inverses of each other. Let's check part B. We want to see if f and g are inverses of each other, which means FOG and GOF both must be equal to x. FOG of x means f of g of x. That means start with function f and replace the x by g. If I distribute, To drop the parenthesis, 1/2 times 2x, 1/2 times 2x. 2 and 2 can cancel each other, so we get just x. 1/2 times 8. We can simplify 8 and 2, so we get 4. 1 times 4 is 4. And don't forget to we have a plus 4 after the parenthesis. And then, if we combine like terms, -4 plus 4 will cancel each other because it gives you a 0. So the final answer is x. Okay, I told you if the two functions are inverses, FOG and GOF, both of them must be equal to x. And you see, we got only x at the end. Let's check the other one. Finding GOF of x, which means G of f of x. I'm going to start with function g, -2. Oh, sorry, I was looking at the other one. So function g is 2x minus 8. And replace the x by function f. Distribute 2 times 1/2, which is 1x. 2 times 4, which is 8. There is also a -8. Just bring it down. And combine like terms. And you see, oh, again, we got x. When both of the FOG and GOF end up to just x, they are equal to x. That means the answer is yes. They are inverses. So function f and function g are inverses of each other. So every time question was asking you to determine if the two functions are inverses, you always need to check these two, FOG and GOF. But now let's see, how do we find the inverse of a function? Okay, if the two function was given to us and just asking about if they are inverses, we know how to check. But if we only have the function and we want to find the inverse, what should we have to do? As I said, we always show the inverse by f inverse of x or f -1. That -1 is not a power. Please don't get confused yourself with the power. That's not a power. That is just a notation to show that's the inverse function. And we read this one as the f inverse of x. And to find the inverse function, first of all, we have to make sure that the function is 1-to-1. Otherwise, even if we find the inverse, the inverse is not a function. We have to make sure that the function is 1-to-1. That means for every one y value, we just have one x value. Then we have to replace f of x by y. Then we need to switch x and y, and then solve the equation and isolate the y in the new equation. That's it. That's all we do. We are going to follow the steps here to find the inverse. Let's look at this example. I have function f. I want to find the inverse. First of all, is this a 1-to-1 function? Yes, it is. You can also use Desmos graphing calculator, type this one there, and graph the function. And you see the graph is a straight line. And if it's a line, it's 1-to-1. Because for every one y value, we just have one x value. Every horizontal line only cross the function at one point. After making sure that the function is 1-to-1, we need to replace f of x by y. Then we need to switch x and y, which means instead of y, we just write x. Instead of x, we put y. After switching x and y, we need to solve the equation and find the y. When we say solve for y, means isolate the y. Y is on the right side. To isolate the y, I need to move 9 and also get rid of 2. To move 9, I'm going to add 9 to the both sides. So we just have x plus 9, which is equal to 2y. Then to cancel 2, since 2 is multiplying, I will divide both sides by 2. So now we have y, which is equal to x plus 9 over 2. Y is isolated now. This is my inverse function. But just Since at the beginning of the for the first step, we replace y for f of x. Now I'm going back and replace the y by the inverse function. And the inverse function notation is f inverse of x. Instead of y, I will write f inverse of x. But the other side is my inverse function. That's it. So this is the inverse of that function. Let's do another example. We have a radical function. First, step one. Is this a one-to-one function? Yes, because if you graph it, you will see that it is a one-to-one function. Step two. Replace g of x by y. Step three. Switch x and y. Step four. Isolate the y. To isolate the y from the right side, I need to add 4. I need to get rid of the radical, and I also get rid of 3. First of all, I need to add 4 to the both sides to move 4. Then, to cancel the radical, I need to s-square both sides. When the index is 2, we need to raise it to the power of 2. Because power and radical cancel each other, so we just have y plus 3 on the right side and x plus 4 with the second power on top. You don't need to raise it to the power. You can just keep it with the parenthesis and the power. Then, to move 3, we need to subtract 3 from the both sides. So y is equal to x plus 4 s squared minus 3. Since this parenthesis has a power, we cannot add or subtract the numbers together. So you just have to keep negative 3 outside of the parenthesis. When y is isolated, that means you have your inverse function. But it's better to replace y by f inverse, the notation of the inverse function. That shows that is the inverse function. So replace y by f inverse and then the rest of the equation. See. And the last question, to find the inverse of this function, as you see in this function, it says x must be greater than or equal to 5. And the reason for that is if you graph this function with this most graphing calculator, you will see that the graph is something like this. And this is not a one-to-one function. Because if you graph any horizontal line, it will cross at 2 points instead of 1 point. But when it's mentioned that x is only greater than or equal to 5, it means that only from this point, only look at this side of the function, the blue side. Is this function one-to-one now? Yes, because any horizontal line only crosses the function at 1 point. And this is only for showing you that this function is one-to-one. That's it. You don't need it anymore. After making sure that the function is one-to-one, now it's time to replace j of x by y. Switch x and y. Isolate the y. Isolate the y from the right side means subtract by 1 to cancel 1, square both sides to get rid of the power, and add by 5 to get rid of 5. So we do a step by step. Subtract 1 first. Square both sides to cancel the power. And then add 5 to the both sides. And remember that you cannot add 5, which is outside of the radical, with anything inside the radical. You just need to keep plus 5 after the radical. So I got the function because I isolated the y. Now I can replace the y by f inverse. So I say the f inverse of x, it's not f, so I'm sorry. The function's name was j of x. I did the same mistake in the previous question. That's not f of x, it's that function name is g. So g inverse of x. This is a j inverse of x. Is the square root of x minus 1 plus 5. And that is the answer.